I'm a boat builder from the Cotswolds in the UK, and I'm currently building a boat called Temptress, designed by Michelle Berrier and kitted by myself to be built utilising the latest in CAD design, CNC cutting and modern epoxy wood construction. If you've been following this series, I'm sure you've heard me say that many times already. In this video, we're going to be CNC cutting some more parts. So in the previous videos, what we've done is we've CNC cut the parts, we've assembled some of the frames. Those frames have gone back onto the CNC machine and I've cut the bevels into them to pre-shape them for landing all the timbers within the boat. I've also laminated the stem and then CNC carved the stem to again receive all of its timbers with its relevant bevels pre-cut. In the last video, we set up the CNC cut strongback, which is going to help to position all of these components within the final assembly. And I did a trial setup of all of that of the forward end of the boat to see how things were going to land and to see how this process was actually working out, because this is a very new experimental thing for me. I haven't tried doing this within boat building before, and I wanted to see how all of this beveling was actually going to work with the timbers that landed onto it. And I was very pleasantly surprised it actually worked really well, so that's really good. So what that means is that it's confirmed that everything that I'm doing is working, so I can now roll that out throughout the rest of the boat and build all the rest of the frames and press on with getting some more stuff built. So I need to cut a lot more components. There are a lot more frames to do, still another 10 frames to build plus the transom as well. So that's what I'm doing here. I'm cutting a load of the components for the rest of the frames we need. So in this video, we're going to take a look through the CNC cutting process for the frame components. I'm going to share with you how I create the toolpaths within Fusion to cut all these parts. I'm going to show you my recommended method for holding down and cutting solid timber boards to get the absolute best finish on the parts and best dimensional sizing for them as well. I'll also show you how I nest these components to make the best of the grain orientation and colouring within the various parts that we'll see on the board and how that's going to reflect through into the finished boat. So let's get started with that. We need to get a board first of all, and we'll get the first sheet of components cut. Okay, so when I've been cutting frames previously, I've had a couple of questions about the way that I set this board up, why I do it like this. So I'm just going to explain my reasoning behind the way that I cut these frames like it. Now, firstly, I do not thickness this board before I start to cut these parts. The reason for that is to get efficiency out of this stock. Now, the finished part that I need to end up with is 22.25 millimeters, and I'm aiming really for something between 22 and 22 and a half. That's plenty of tolerance to hold on this. Now, the boards that I'm using are a 1-inch stock, but they generally end up finished around about 26 to 27 millimeters. Now, as a rule of thumb, if you're going from a sawn board to a thickness finished board, you need to allow around about 1/4 of an inch to clean up both faces correctly and efficiently without leaving sawing marks. So if I was to use pre-machined stock and size the thickness of my parts before cutting them, I would have to thickness the full width of this board, and that would probably involve losing 6mm off the starting sawn thickness. If I did that, I wouldn't be able to use this stock size, and I would have to go up to the next stock size, so I'd have to be buying 32mm stock rather than 26, 27mm stock. So it would be a lot more cost for timber. If I do it this way and I cut sawn parts, because I'm just sizing down just purely the section of the finished part, it generally means that I haven't got to account for cupping across the board and such wastage, so I can size the final part a lot more efficiently, and I can get down to 22.5mm as a finished size from a 26mm sawn board. That's quite efficient. That doesn't normally happen within timber work. You're normally wasting a lot more material to planing. The other reason that I do it this way is that with the increased thickness there, I can cut the full height of my part and leave what I've called this onion skin on the bottom end of the part, and that is how I'm holding my components in place. This, in my opinion, is the best way to cut solid wood parts on the CNC machine and get them incredibly accurately sized and really well finished. It maintains fantastic board integrity, which is a really important thing when cutting things like this, particularly with solid wood timbers. As you cut these parts, the board can break and fall to pieces, and basically your entire clamping system goes out the window. Vacuum is not an option on solid wood boards like this. Some very powerful vacuum systems might well hold down this board, but given the size of some of these small parts that I'm cutting, there is no way that a vacuum system would hold that, particularly for the type of cuts that I'm running. Let's take a little closer look inside the board, and I'll show you what all of that means in a bit more detail. So there is a finished board, a typical board for what I'm cutting. So you can see that with these small parts here, even after they're cut, they're still incredibly firmly in place. There's no movement in that whatsoever. And that is due to this onion skin, this little layer that I have left. And you can see it just on this side that's broken out here. So you can see we're leaving around about 2mm in the bottom of the board that is holding all of our parts in place. And that's really important for board integrity. If I was cutting right the way through this, what we would normally do is use a tab to hold a part in place. So say we'd have a little section across there that we leave, the cutter will come along, come up and over it. And that does work, but the trouble is, in order to get all of this to maintain integrity with tabs, we'd need to put a huge amount of them in. And if you look at this section here, you can see why that would be. So in order to make sure that this part can stay still, it's going to need to have probably 4 tabs on it. But what you also need to do is make sure that those tabs hold this piece of waste in place so that it can also maintain the integrity of the board as a whole. So you think for this part here, what would normally be 4, 5, maybe 6 tabs that would hold it in place, in actual fact, in order to maintain its hold, it's going to really want a tab there and there, at least 2 to maintain the hold of this part here, at least 2 on that scrap piece. So you'd be talking probably 20 tabs all in all. And the reason we have to maintain the integrity of the board is so that the clamps that are holding it in place out here, so that that clamping force keeps that part bound to this part, which is bound to that part, so that all of these can stay in place. Otherwise what happens is when you cut through the part, the whole board just starts breaking to pieces. And that can work occasionally if you're cutting parts like this and you come around, you cut all the way through, and as you finish the part off it just breaks loose, and that's okay for some parts that you're doing. But what I'm actually doing here is I'm doing a finishing pass. So I do my roughing passes that cut down with the cutter. So what my cutter does is it comes down and it does one cut there, then it'll go down to its full depth and it'll do a second pass down there, and then on the final round it will go around the part again and just index in slightly so it's right up against the piece. What that does is takes a lot of the load off the cutter. It means you're doing one cut at full depth, so you get a really good finish to the edge of the part here without any ridges between cuts, and it just does a final dimension of the part. and it takes the load off the cutter because you're essentially cutting in a trench as you come down. But then when you do the final finishing pass and you come over slightly, you're actually just cutting on the inside edge of this cutter, not both sides of it. So it gives you a really, really neat, accurately sized dimension part. Now if you're doing that where you cut around this part and it breaks loose just as you finish the final pass, there's no possible way that you can do a finishing pass on that, because your part is then rattling around and you're highly likely for it to chatter about and end up damaged. So that is the reason that I do my solid wood parts of this type anyway with the onion skin method. It means that they are incredibly well supported and strong, and you can see even after I've cut the whole sheet, this sheet is still really rigid. So most definitely my recommended preferred method for accurately cutting parts with solid wood. The other thing you've got with tabs is that they are, even if you've got a reasonable tab say along here, because you're going to be in the direction of the wood grain, they can split down the centre. We all know what solid wood's like when it's long, short sections like that. A tab can quite easily break like that, and as soon as a tab breaks, your part's loose, your boards fall into pieces, and you lose all sense of accuracy and reference, which you don't want to do. Now when it comes to releasing these parts from the board, there are a number of different ways in which you can do it. You can use a little flush trimming router bit, and you can run that round the board from the other side, and you can just use the bearing guide on the flush trim bit to follow your already cut part and just trim it out. Or you can run it through the sanding machine like I do. So because I've got a sander that will take this through, I turn the board over and I sand down the back edge until we start to break all those parts free, and then once they're free I can put them in the sander and finally dimension them. So that's the method that I found works really well. I've cut a lot of solid wood components on the CNC over the years, and this is by far the best way to hold them down and be 100% sure that nothing's going to move, because the minute something moves, you've 9 times out of 10 you've completely ruined your part and you've got to start over. I don't want to be doing that with this nice expensive utility that I'm using. So let's get this off the table and get the parts released. So I've spoken briefly before about nesting that I've done within this cutting process. Now I'm doing this manually, which is a very long-winded way of doing this. There are certainly quicker ways to do nesting, certainly in other programs, and in Fusion as well. There's a much more automated process for doing it. But the reason I'm doing this manually is that I am laying all my parts out on a per frame basis. So I'm picking a board that has got the correct color and grain orientation for the frame that I'm working on. So I want to select the individual parts for that frame and manually position them so that I know that I've got perfect grain orientation for that part and perfect color. So what I've done here is I've just extruded all of my parts. So I'm cutting from solid wood some of the parts that I would propose that you do in plywood instead. I'm doing all of those individual frame components except for bulkheads in solid wood. So I've brought all of those into Fusion together and I've extruded everything that I need, and then what I'm doing is I'm just laying them out one frame at a time into their boards. So I go out into the workshop, I select a board for the frame that I'm working on, I measure it, and then I draw it in Fusion so that I've got its dimensions, and then I lay my parts out on that board according to what those parts require with regards to grain. So you'll notice that all of my long frame components, so that's going to be the frame bottoms and the frame sides, deck beams, things like that, I tend to keep those towards the edges of a board, particularly on the wider boards that I'm using. What you might notice with some of these boards is that towards the outer edges you've got much straighter grain, and then towards the inner sections of the boards you've got more of a crown cut grain, which is where you'll see these big kind of swirls, and that means that if you look at the board end on, you've also got more of a rounded grain, whereas what we want for our frame components, certainly the long components, the bottoms and the sides, is a very straight grain and as vertical or as close to quarter sawn grain from an end grain point of view as possible. So we'll generally see that on the outer edges of these wider boards. So I want to position those components towards the outside of the board. Things such as our gussets and our keel fillers, chine fillers, things like that, they're not quite so critical in that respect, and they're much smaller parts, and they're not going to experience the same sort of movement that we might do on longer straight components. So that's another reason for me nesting manually, is that I can go out into the workshop, I can look at the board, I can see what the grain's doing, I can come back in here and position my parts accordingly for what's going to work best for them. And I also try to keep matching components close to each other on the board. So if we've got one frame, I want the two sides from a similar section of the board so that they're going to be a similar finished colour when they're within the boat. So very time consuming way of approaching it, but this is exactly the same way that you would do it if you were cutting these parts manually with a bandsaw. You draw them out from templates or patterns, or you loft them onto the board, and you do this exact same thing. You'd still select the part of the board that you want for that component based on the characteristics of the grain. I'll also give you a quick walkthrough of how I do the tool paths and what they actually look like within Fusion, so what we're cutting here. So I'm drawing my stock board in Fusion. I've got a rectangle that matches the size of my piece of stock out in the shop that I'm using. And once I've selected that board, I can model that in 3D, and this just allows me to get a really good visual representation of it. Then the first thing that I do is I put some holes into this stock on clearance positions. So this is going to indicate to me where I can put my clamps, and they're going to be nice and clear of the components as the machine cuts them. To begin with, I was using clamps and holding down the parts, but I've actually moved over now to using screws through into the spoil board, which just accounts a little bit better for the varying width of the boards and gives me a bit more scope. And a screw also keeps out the way of the machine very well and avoids any problems with fouling. So it's a good way to go, I have found. So I'm running 3 operations to cut these parts. First of all, that's a marking operation. So what that does is it just dots around each of my screw hole or clamp hole positions, and it puts a little mark into that board that indicates to me where my clamps can go. Now I run this operation before the board is clamped down, so I position it, I get my origin that matches my origin, which is down here in the bottom left hand corner of my board. I make sure that my machine origin matches that, get my board positioned, and then I run the first marking tool path without the board clamped down. We're only doing a very light score of the surface here, and the machine is perfectly capable of doing that with the board just sat there under its own weight without anything moving. Then we go on to a bore operation. So what this is going to do is drill all of the reference holes that position all of my relevant parts within the frame construction board, and we've seen this used a lot so far. So what the bore program does is it does a little spiral in, so the cutter comes down in a spiral motion, which is really good for clearing the chips out of the way and keeping a constant even pressure on that cutter. And then it does a finishing pass, so it'll go all the way down to full depth, and then it does one lap around the outside just to give a really clean inside to that hole. And you can just see in that tool path there, we've got the spiral that runs down through the center, and then we've got the outer finishing pass that just cleans up that hole and gives me a really accurate 10mm dimension there, because these are alignment holes, they want to be really nicely sized. Then finally we're doing the contour tool pass, so this is what's cutting all the parts out, and you can see what's going on here. We cut at 3 different depths here, so I do 3 passes around each part as we come down to full depth, and then you can see this final line on the inside here that is the finishing pass that I mentioned earlier. So that comes into our part, does a final dimension, and gives us a really fine finish along the edge of those components, as that relieves all the stress off the cutter, and it's just taking a tiny little skim, and that skim's only about generally 10% of the tool's diameter. So what we're cutting on that final pass is around about 0.95 millimeters material removed there, so it's a tiny little skim off the outside. Once I'm happy with that tool path in here, we've just got to export that and get it ready to take down to the machine. So we do what's called a post process, and that exports the code from Fusion which our machine wants to see. And that is basically just a list of commands that tells our machine what to do. A lot of people think that these CNC machines are very clever. Well, in actual fact, they're quite dumb machines. They just do what the software tells them to do. The software is the really clever part behind this. So what actually comes out of Fusion is just simply a list of commands, and most of that is just positional stuff that tells the stepper motors within the machine where to go. So we get a huge list of dimensions here, and that is Fusion telling my machine where it should be. So we take that down on a USB stick to the machine downstairs, we run that program, and it follows what it's told to do. So this is the kind of finish that we're looking for with these components. You can see we've got no steps there between passes as we've cut at various depths, and that's due to that final finishing pass that we do. You can see we've got a beautiful finish around the outside of that part. No burning anywhere, even on our internal corners here. And we've got a really accurately dimensioned piece. So that is exactly the sort of finish component that we're looking for. This is a component that I've cut with a slightly more dulled cutter, so you can see the slight difference there. We've got a little bit of burning around these internal edges and sort of fuzzing to the outside as well, so not quite such a good finish, but nonetheless an equally accurate part and still perfectly good for what we're doing. Okay, so that is the next stack of parts cut for the next batch of frames to build within the boat. Apologies if this hasn't been the most exciting video, but this is just the next step in the process in building a load more frames, and it is a very essential part of the boat to make sure that these are cut accurately and we've got correct grain orientation. So not the most exhilarating stage of the build, I'm afraid, but essential part of the process nonetheless. So I hope you have at least found the video interesting and there's been something in there that may help some of you guys if you're cutting CNC parts or building one of these boats for yourself. Another little plug for something that I've been working on is my new CNC woodworking course, and that has pre-launched this week. So if you're interested in learning much more about the CNC woodworking process, take a look at the link in the description below this video and you can currently get a very discounted pre-launch enrollment price should you be interested in that. As always, I want to say a massive thank you to the patrons and sponsors that are supporting this project and helping it to be a realistic possible thing to happen. Very much appreciate your support because that really helps outside of the revenue that I get from the videos, and it makes all of this possible. So thanks very much for that, guys, and thank you for watching the videos. Very much appreciate that as well, and I will see you in the next one. Cheers, guys.